Okay, so here's a file with some statistics plots in it. And so we import the matplotlib pyplot as PLT. I imported random as RN to make some random numbers. So I set the seed so that we would get repeatability or reproducibility from this stuff. So I made 3 sets of data. So I made a nested list. So here's the first set of data. I did a uniform distribution between 0 and 5. So that's continuous, so it can make fractions and that kind of thing. And I did 10 of them, then I did 20, and then I did 30 just to kind of show, you know, we can do different size data with this. You can do all the same size, that's fine. I wanted to create labels on the x-axis for each of these, so I did an n equal 10, an n equal 20, an n equal 30. Now to do, and I'll do it kind of both ways, and we'll see that probably this first way is, if this is what I'm doing, probably this first way is better. So I'm going to put multiple box plots in one plot, one axis. So you say figure, comma, and then the name that you're using for the plot. And now here you don't and we'll see, you don't necessarily need this thing with the box plot 1 and all this necessarily, but it's assigned here to a variable. You could just write ax.boxplot, but the thing is, in this particular case, we're going to use multiple colors. So pink for the first one, light blue for the second one, light green for the third one. You could always experiment with different colors. But this is how they do it. So they say for patch and color, and here they use a command zip to zip these boxes, so there are 3 of those with the 3 colors. So if I only had 2 colors here, I would probably get an error. You know, the number of colors needs to match the number of boxes, and that's why we use this variable here to set this up. So there's the data, the 3 sets of data. 0 for vertical alignment. I think if you use a 1, it would make the boxes go sideways, which would be fine. But typically you have them go vertically. Then this patch artist true, so this is what is allowing it to fill with color, and then I'm giving it these labels that are here. So I'm telling it to use all those things to make the box plots. I set a title that'll go on top. Here's the color stuff, and again 3 colors, and the zip is putting the 3 boxes or 3 box plots with the 3 colors. And then you know, it says set patch set face color. So this patch is the thing that's filling in. So here are some things, you know. So grid is true. I made an X label in general, 3 separate samples, Y observed values, and then you say plot show. And if I just run that, I'll get this first set of box plots here. So this looks really nice, you know, so I've got the n equal 10, n equal 20, n equal 30. We'll go and kind of look at some of these options and so forth, but so this is an outlier on this first data set. You'd have to read I don't remember the rules on their outliers. Typically an outlier is say more than one standard deviation, or well actually, so from the median it's maybe more than 3 standard deviations out or something like that. Yeah, there are various definitions for outliers, but so that's what that circle is. It's a data item, but there's none in between here, and they're saying that's an outlier. There were no outliers in these two data sets. But that's a nice looking plot. Now we could have done them separately. So here's 3 separate plots. So what I do here is, now I tried this tight layout false. It didn't seem to do anything. So there's a tight layout you can use, and I'm not exactly sure how that's different. I do know with a histogram, I tried using a histogram with a tight layout true, and it didn't like that. So I changed it to false. I tried making this one false to spread these out down here, and we'll see in a minute that, yeah, it just didn't seem to work, and that's part of the reason this option just doesn't look very good. But so I needed 3 separate labels, so I had set 1, set 2, set 3. Now here, so I do that same sort of fig. I used a different name, AXS, and then the plot and subplots. But back here, see, it just said subplots and there was nothing in there, and that put the 3 plots together. But here I'm saying subplots, and I'm saying 1 by 3. So 1 row, 3 columns, or 3 different plots. You know, if I wanted to do 4, I could do 1 by 4, I could do 2 by 2. And then once you do that, the indexing works just like any list or nested list. If I did 2 by 2, that would be 2 rows, 2 columns, so that would actually be a nested list, and I'd need 2 indices for which row and which column. But so here's the first one of the 3, so index 0, and I use 3 sets of 0. Okay, because again, this was right. So I had a list of lists. So I'm taking this first list of the 3 sets, and then vertical alignment. Notice I didn't do anything with patches, but I did set the label. And notice I didn't set this equal to anything. I just did the box plot thing. And then I set a title, data set for n equal 10. And then I did the same thing for the other 2 data sets. Used label 2, label 3, set the titles differently. And then for all of them, I said, you know, let's do a y-axis grid, true. So I did that for all 3, observe values and so forth. And they look sort of okay, but notice the observed values. These go with this plot, yet they're overlapping in this one. So there might be something to space these out more. I wasn't sure what that was and didn't want to take the time to look it up. Certainly I could just take that observed values off of these 2. So, you know, if I did that real quick, these would look a little better, and they'd still be fine. You know, if I comment that out and comment this one out, and then run that cell. You know, that does look better. But notice the scales aren't the same. I can make the scales the same back here. So like I say, this tight layout doesn't seem to do anything. But I can make the scales exactly the same if I say share y, looks like Sherry, but it's share y equals true. And so, you know, look here, see the scales don't match, but now they should if I run this. And see, now the scales match. And so this is looking better this way. So if I get rid of the you know, the axes label here and here, and if I share, which is probably the better thing to do anyway, if I share the axes, you know, this is looking a lot more like this one, but I still like this one better. And you know, you could experiment and set different colors on these, but if you're going to do this different colors and so forth, just do it all together. All right, so we made it look a little better. So what I'll do is when I save this file and put it in Blackboard, I'm going to save it this way, that I changed it with the share y and getting rid of those values. But again, I would suggest using, if you're going to do multiple box plots that you want to compare together, I would just do them all in one plot. But you can do them as separate. Now, and so here I went to the user guide, which I have links for in Blackboard. And then once I was in the user guide, I went to examples. And so you see this says examples. And I scrolled down, I found statistics. And I clicked on box plots. And that gave me, I don't think this page, I think it gave, I gotta find it now, let's see. Might have given me this page. That's down here somewhere. But you see there are all these different things. Unfortunately, they're not like in any really good order. Box plots. So, you know, I went here and I don't remember if I came exactly to this one, but I was somewhere in here with the box plots, and you know, I looked at this and it gave me some examples of how to do things, and you know, this is where you can see the vertical versus horizontal alignment, and that was, see, there's the zeros for oh, this is yeah, so this one was horizontal boxes, yeah, I don't know how these, I thought that was with a 1 to make a horizontal box. Those are zeros, so I'm not sure how they did that. But then down here, you know, they do the multiple box plots on one axis and show that. Now here they didn't add any colors, but this has the custom fill colors, and that's where I got a plot that looks like that. Okay, so, you know, I went to examples and I hit box plots, and I was in here somewhere with the box plots and just started kind of clicking on various things. Okay, so that's box plots. And Then histograms, that's a good thing to get. And so here I thought histogram might look a little better with some normal random data. So I did a Gauss, random variable Gauss with a mean of 20 and a standard deviation of 4. I did 1,000 of them to really fill in the histogram nicely. Again, I use that same random seed. I changed the name here, HST instead of AX or AXS. Yes, and you'll want to do that because otherwise, if you're using all in the same file, it could start messing things up. And so I just used a different name other than AX. You know, there's nothing, you could use anything you want. And so here, you know, I did a 1 row 2 plots because I wanted to compare the different number of bins. And so it will automatically take the data and you just tell it how many bins you want and it'll set it all up. You can set an X label this way with a histogram. And so you see again I used, you know, the first plot and then the second plot, index 0, index 1. Here I use the share y equals true. Here I had to use the tight layout false. It gave me an error when I had true. And I think I copied something like that from possibly from a histogram thing, but it did not like it. So anyway, notice, you know, here are the 20 bins, here are the 40, and this is much taller because there should be, if I'm only using 20 bins, there should be about twice as much data in each bin. Oh, so it should be about twice as tall. And you know, so there are the histograms with their frequencies. Now, if I got rid of the share y equal true and I changed that to false, or just didn't put it in there, and I run this, notice they look like they're the same height, but as you look, see that's 120, that's 60, so this really is half as tall, but I can see it better, you know. So it's a little misleading though, you know, so I would say you want this to be true if you're going to be comparing them. You know, so lots of things, you know, and here's histograms, and again, there's the basic histograms, and that gave me, you know, some idea of what to do. You can change colors again. You can look at that and see how that works. There are 2-dimensional histograms, so if you got stuff going in 2 directions, this is things I'm customizing. I didn't look at all that, but then, you know, there's some features, so that's, I think, where I found the, yeah, see they've got smarts here for an X label. So see, I saw the set X label, set Y label. They've got a set title, just like we had before. You know, but you can explore his type. Now I did wonder, now you got like step and step filled, bar stacked, and bar, and so forth. Now I guess with bar, you or maybe any of them, you can do unequal bin sizes. Generally speaking, I don't think you want to do that, but it is possible. So you can see that there's stuff there. But you know, but I wanted you to see you can make a basic histogram, pretty straightforward. And then I came down here and I did it again, but this time when I made the normal variables, I actually rounded them to ints and did the same thing. And now notice if I do 20 bins, it looks pretty much the same as it did before. But if I go to 40 bins, because I went to integers, there are some integers missing in there. And you can see that with 40 bins because, not that would, if, I'm going from 0 to 40, so that would be about 1 bin per integer, and and so not every integer that is there, and it's missing. So that's just, what I was wondering. I tried using a different type, with bar or whatever, and but because I was trying to, if you use integers, you probably don't really want to use a histogram per se. You really want to use a bar graph where the bars don't touch. But that I didn't come up with how to do that. So there may be a way by setting the, using the bin structure and all that, setting your own bins manually, you might be able to do that, but I'm not going to worry about it. And then finally, scatter plot. So, here's scatter plot. I went up here, it's near the top, yet it starts with S. Yeah. But I found scatter plot, and they got some interesting different scatter plots. They don't seem to have just a straightforward scatter plot item here, but it's just a straightforward scatter plot. You need data. So here what I did to generate the data was I generated X from a uniform distribution from 0 to 20. So I got a bunch of X values from 0 to 20, 100 of them. And then I generated an error function. So that was a Gaussian or normal distribution, mean of 0 and a standard deviation of 2, same size, 100 each. And then to make the Y data, I came in here and I made an empty list, and then I went for I equal 0 to 100 or 99. And I said, well, take 3 times the X value plus 7. So that gave me a line of basically 3x plus 7. But then I added this error function to it, and that spread out the data. Made it look errorful, like real life data tends to look. Still, that looks like a really good straight line. And if I up the standard deviation, say I put it all the way up to 5, and I ran this, it starts really spreading out the data more, and I could play around with that and make that really big and really spread out. I guess if I made it 50, probably my data really wouldn't look much like a line with slope 3 and so forth. So let's see. Yeah. See, it looks pretty random at this point, right? Just totally random. Why? Well, because there's still a line in there of 3x plus 7, but the error is so big, it's overshadowing the line by quite a bit. So that's just a way I made some data. If I just had a data set of real life data, then that would be fine. I would just use that as my data set. If I had an X and Y, then that's what I would use. A data set with X and Y data. But there you go. That's a scatter plot. And it really didn't take much. I mean, here's the actual scatter plot part. right there. So I just call it SP for scatter plot, and then said sp.scatter of the X and Y data, and there we go. You know, so again, if I had real X and Y data, you know, if I had, say, a list of ordered pairs, then I would need to get to the ordered pairs on that. We could try that real quick. Here, let me, I'll add this to the, because I haven't actually tried that. Let me just kind of highlight everything here. Copy it and paste it down here. But now I'm gonna, I'm not gonna do random stuff on this one. I'm just going to, so get rid of all of that. And let's just say I have data that equals, and suppose I have it as ordered pairs. Let's try that. So like say 1, 2, we'll just get like 4 or 5 data points here. So 2 and 5, and then 3 and 6. 4 and 10, and do 5 and 10, I guess. Okay, so there's my data. Now I want to do a scatter. I need the X and Y. I haven't tried this, so we'll see what happens. I'm just going to say data. See if it handles it. May not. That's okay. So let's try running that. Yeah, it didn't like that at all. Right, missing one required, you know, so you need an X and a Y. And so getting your data in that form may not be a good idea. So, you know, if you had your data in that form, well, I guess we'd need to go through and get those ordered pairs. Let's see. Yeah, I don't think it's going to work to say like data of 0. Because see, that's going to give me the 1, 2 ordered pair. So, you know, if you got data as ordered pairs, I think you'd probably have to go through and strip all that out and get the data that way. You know, so, but on the other hand, if your data were a nested list like that of the X's and then the Y's, so if it's 1, 2, 3, 4, 5, and now this one, if we have our 2, 5, 6, keep going, 1 too many there, 10, and 15, or 10 I guess it was. If we do that, now I should be able to say, oh, let me pause this. My phone is ringing. Okay, so yeah, so I got the data, and I'll say data 1 and data 2. I think this should work. And there we go. Oh, now notice this is the whole SP thing. I think the fact that I have SP up here, this is what I mean by it can get screwy. Let me put a 1 here and a 1 there, and hopefully that will fix up the fact that it's plotting these two things here. So cell, run cells, yeah, see. So you got to be careful with the names. It may or may not screw things up, but it did in this case. Okay, so we've got that. You know, here I haven't added any titles or legends or anything. You know, that's something that you can look up with all this. And there's always Google too. You know, you just Google matplotlib and things like scatterplot titles, you know, stuff like that. Axes labels. You know, because we've already seen that there are a couple different ways. You know, here's one way to do an axes label that's for histogram, and then here's a different way to do axes labels, you know, up here for the box plots. So, you know, it can vary from type of plot to type of plot. But there we go. There's 3 different stats plots that are very useful: box plots and histograms and scatter plots. And so I think we'll stop there, and I'll get some homework set for you.